Okay, good morning, afternoon, or evening, depending on when you're watching. This will be, I'm redoing the first unit here in Precal 20, making some fresh videos, and this is the first unit in series and sequence, which we're going to start today, day one. So let me pop up my Blackboard here. Let's hide this out of our way here. Let's get this particular notes up here. And okay, so what I suggest as you're going through is you can follow along. We're going to do these things today. Hopefully that we'll keep the videos in that 35-minute to 40-minute range. Let me open up on the side here so I can keep track of time. Right there. Okay, so what we're going to do today is we're going to look at series and sequence first day. So we're going to look at terms first in terms of study of sequences. What's a sequence? What are all the important things in there? What the variables mean and things like this. And we're going to look at three different examples within the study of arithmetic sequences, which is section 1.1 in our text. And then we'll do some practice work, or you'll do some practice work from the text. So let's start off with terminology. And we're doing 1.1 first, and that is arithmetic sequence. So obviously we want to know, what is an arithmetic sequence? Oops, it's got to have an E in there. Sorry, let's spell things right here. There we go. But when I say the word arithmetic sequence, this means that it's a list of numbers with commas in there that they have the same common difference between each subsequent term. Okay, so this would be a list of numbers that have the same common difference between consecutive terms, let's say. What does that mean physically? Well, if we do an example here. So, for example, if I just started with a term, say 7, and then I was going to add, like, say 3 to each time. So 7, add 3, 10, add 3, 13, add 3, 16, add 3, 19. And that would be an example of a terminating, one that finishes, arithmetic sequence. 7, 3 more 10, 3 more 13, 3 more 16, 3 more 19, etc. You can also have ones that don't finish. So example number 2. So let's say I started with a negative number. Let's say I had -5. And then I was adding, let's add 8 to it. So I add 8 to it, you get 3. I add 8 more to that, I get 11. I add 8 more to that, I get 19. I add 8 more to that, I get 27. And let's say that I was going to continue doing that infinitely. So we can do that by putting 3 dots here, meaning that this arithmetic sequence, even though it doesn't have a final term, it keeps on going. Okay, so there's an example of an arithmetic sequence that stops. Here's one that keeps going. They have, between the common consecutive terms, there is the same difference between the numbers. You're adding the same number. Now you might say, hey, Mr. Inglet, could you subtract? Yes, you could. So if we had one, say an example like this, say I started with 12, and then I added a -4. So 8, and then another -4 would be 4, and then another -4 would be 0, and then another -4 would give you -4, and then, oops, let's put a comma in there, pardon me. And then another -4 onto that would give you a -8, and so forth. And ... if you want, or you could terminate. So yes, it can be subtractions as well. It doesn't always have to be going up or adding upwards. So there's 3 examples of what we would call an arithmetic sequence. So in terms of what we need to know about the terms in an arithmetic sequence, we have This term being very, very important, the beginning term, we call that the first term, obviously, and we have a special name for it. And then the difference between each subsequent term, we have a name for that, common difference, and we have a variable for that. So we're going to define these things. So the first term is important. Okay, so the first term, we're going to call that, it's a little t with a subscript 1. So I have to subscript this usually. So I'll go down here and use my subscript tool, and it looks like that. Let's bring that up so you can see it better. So there's the symbol for first term, T1, and this basically is the starting term of the sequence. Starting, that's okay, and then we have the difference between two consecutive terms is called the common difference. Okay, and the common difference is a little d for a symbol, and this is the difference between two consecutive terms. Okay. I recommend keeping your own notes as you go. I know I post the notes up online, but it's always a good idea to help yourself make connections when writing your own notes. You don't necessarily have to, but you might want to print them off and add things to them. However you want to do it. I don't have the neatest writing, but I recommend doing your own like it was a normal math class as you're going through. Okay, and that's why I do them with you, and I don't have them all pre-made and go through them. I try to treat it like a regular type classroom situation. Okay, so that's common difference. And then something called the general term. This one's a little confusing. Okay. It can be any particular type of terms. It's usually called Tn, or the nth term, if you like. It's another word that they use. So it's T subscript n. So it could be the 9th term, the 12th term, the 15th term, and they'll have that n will represent different numbers. Okay, so if we want to talk about the final term, it's usually Tn. And this is the nth term in the sequence. So if we look at our examples above here, if I'm talking about this one, we can still see here. If I said, well, what is the 4th term? T4. That would be 1, 2, 3, 4. It would be 0. So T4 would equal 0. Okay, and that's what the general term means, so Tn. So this n can represent any particular term you're interested in finding. It might be the last term, it might be the middle term somewhere. It's just called general term. Okay, the other thing that we need to know is number of terms, okay, in the sequence, and that's the n. Okay, when we talk about number of terms in the sequence, we're talking about a little n like that. Okay, and this is basically just how many there are. Okay, so if I'm talking about this example, we can see here, we can see that this sequence has 1, 2, 3, 4, 5, 6 terms. So the n value of this sequence would be 6. Now, what about this one, Mr. E, that has 3 dots? Well, that means it has unlimited terms because it keeps on going. But we could stop at a particular one that we're interested in. We might want to talk about the 15th term, so we could keep writing until we got to the 15th term. So there are the definitions that we're going to be using with this particular first section, 1.1, arithmetic sequences. Okay, I'm just going to pause here for a second, and I'll be right back with you, and we're going to do some examples. Okay, so let's start off with the formula here. Now, you don't necessarily need to use the formula. You can write out your sequences by hand and work things through like that if you have a short sequence like these three here. And I'm saying, say we had this sequence here, and I said, what is the, let's say we had this sequence. I said, what's the 16th term? You could keep on writing till you get to the 16th one and then find out what it is. So you can work by hand if you want. However, there's a quicker way to do it if you use the formula. It just saves you some time. So that formula is if you're trying to find any term Tn, which let me use my marker here, and I'll make the line a medium thickness. So if I say any term Tn in a sequence is going to be equal to the first term, whatever it might be, T1, plus, okay, the difference, common difference, times the number of terms that you're dealing with minus 1. So you're going to subtract that first term. So Tn equals the first term plus the common difference times the number of terms minus 1. Okay, so that means that's the formula you can use to. So for example, let's do an example of using this here. So let me pop up an example here. So let's go with typing it here. And let's go in here and maybe we'll make it blue. Okay, and we'll paste it in here. Okay, so here's an example question that I have. Example of finding the nth term. A company hires a plumber. He charges $75 for the first hour. That would be the first term. Then $38 per hour after that. Write the first 5 terms of the sequence. Now, if I'm writing the first 5 terms of the sequence, I don't have to be bothered with the formula here because it's just 5 terms. I can use reasoning and addition because it's an arithmetic sequence to figure it out. So let's keep that there. So let's say A here. Let's go to, let's use red for the answer. So A. Write the first 5 terms. You charge $75. That would be the first term. So then in the second hour, you're going to add 38 to 75. So 38 plus 75, well, if you add that up, it's 113. Okay, the next hour, you add another 38 to that. That would be 151. You add another 38 to that would be 189. And another 38 to that would be 227. So there is the first 5 terms of the sequence. Term 1, term 2, term 3, term 4, term 5. So we don't have to bother with any formula work there. We could just write it out. Okay. Calculate the 17th term. Well, now you could keep on writing for 17, but it would be much easier to simply calculate it. So using the formula. So if we want T17, that's going to equal the first term plus the common difference times n minus 1. Okay, so we know that n equals 17 because it's the 17th term. We know that the first term, T1, is the $75. And we know that the common difference is $38 after that. So common difference, if you're not sure, you just can subtract this from this, this from this, this from this. Any 2 consecutive terms, you just subtract. And that would be our 38. So if I know that, I could just fill it into the formula. So my 17th term is going to equal $75 for the first term plus 38 times 17 minus 1, which would be 16. But we'll write in 17 minus 1. And we'll go 75 plus 38 times 16. Now, order of operations, you do multiplying before you do adding, so make sure you follow order of operations, just like you always do in math. So if you multiply that together, 38 and 16, I don't have my calculator with me, but and then add 75, I think you get 683. Okay, I'll have to dig out my calculator here in a minute. Okay, just double check that. So this would be 3, yeah. And this would be our 17th term, which we could call T17. What would he get paid for 5 hours of work? Well, that's pretty easy. We already figured it out here, right? For 5 hours of work, he'd get paid this amount of money, $38 per hour plus the $75 for the first hour. Okay, you could do that in one of a few different ways, but we already have it written out, so we could write and see he would get paid $227. And that one we've got written out there, so we don't have to use the formula. Okay, so there's some examples of that. Okay, let's do another example here. Given that we have, let's say T1, so example 2, let's say T1 is equal to, sometimes they'll just write it out. Let's say it's equal to 2. And common difference, D, let's say that, let's put a big number in there, negative 88, like that. And N equals 12. I want you to find T12. Okay, so we know that the formula T12 equals T1 plus D times N minus 1. So let's plug in our numbers. T12, we don't know what it is. That's what we're trying to find. T1 was 2 plus D was negative 88 times 12 minus 1. Okay, so if we do that, that's 2 plus negative 88 times 11. So negative 88 times 11 plus 2 equals, what do I get there? Negative 966. So there's a couple of real simple examples of doing just using that basic formula. Now we're going to get into a little bit more complex examples here. We're about at the 17-minute mark, so we're about almost halfway through the video today. So I'm just going to pause and dig up a couple more examples here, a little bit, a few more complex one. Maybe not just finding T1, maybe finding T1 or TN, pardon me. Maybe finding D, maybe finding T1. We'll do and I'll dig up a few examples here. Okay, so I've got a couple here. Let's go to the next page here. So let's move my face over a little bit. Here it is. We'll go to a new page. Okay, and I will click in here, and let's make this blue again. I think I got to click on the blue there. There we go. Okay, so this is an example here of finding the number of terms. So an orchard has 32 apple trees the first year, meaning the first term. Then 12 every year after that. How long will it take to get to 224 trees? Well, this one, you could write it out. You could start with 32 and then add 12 and then add 12 and add 12. And then you want to get to that 224. So you could write it out, or we could just use the formula to make our work a little bit quicker. So I'm going to use the formula here, and I'm going to use green this time for the answer. So if I say Tn is equal to our 224, we don't know N. That's what we're trying to find. How many terms is it going to be before we get to 224 total trees in the sequence? And we do know that T1 is 32 trees. And we do know that 12 every year after. Okay, so 12 more every single year. So T1 was 32, but D is 12 new trees a year. So you could go 32, 44, and keep writing it out until you get to 224, or we could use the formula. Tn equals T1 plus D times N minus 1. Okay, so let's figure this out using the formula because it's pretty quick. Okay, so let's say I had 224 here, and this was 32, and D is 12 times N minus 1. Well, we have to solve for N. So the first thing I'm going to do is I'm going to subtract 32 from both sides. So subtracting 32 from this side and 32 from that side, This is going to give us, what is it, 192 equals 12, and we're going to distribute this with distribution property, 12n minus 12. Okay, now I have to add 12 to both sides. So if I add 12 to there and I add 12 to there, so that's going to be 204 is equal to 12n. So now I divide both sides by 12 and I get n equals 17. So there should be 17. How long will it take? The 17th term, or 16 years. It'll take 16 years because the first year we start with 32 trees. Second year, T2 will be 1 year away from that. So this would be T17 is 204, or sorry, 224, pardon me. T17. So that would be, if we take that first term out, it would be 16 years after. So the 17th year, or if you like, 16 years after the original orchard. The original orchard. Okay, so I will accept both of those as good answers. Okay, so that's an example of finding like an n value. Okay, now it takes us to about 22 minutes. I'm going to do another example here. I'm just going to copy it here. Okay, now this is the hard question. Okay, the one that causes the most issues for you. So we're going to do simultaneous solving techniques, which you learned in grade 9 and 10. Okay, so let's put that example up here. So this will be our third and probably our final example for today, and then I'll give you some practice, okay, that follows along doing these types of examples here. Okay, so let's do a paste in here. Sorry about that. Okay, let's. This is an example where you're given the two terms. You must find the first term and the common difference. Okay, so my example, I'm going to say, let's say, find the common difference and first term if the, what we got here in my example, eighth term is 109. And the second term is 25. This is the hardest type of example. So I'm going to go through this step by step with you. I'm going to move me up in the corner here so I'm not in the way here. Let's get this up here. And let's center this a little bit better. Okay, so we know that here's the only thing that we know. If I go to marker here again, I know that my eighth term is 109, and my second term is equal to 25. So, and I want to find my first term, and I also want to find what's the difference between terms. So I have two unknowns. So when you're solving two unknowns, you need two different equations. So we have to write the general term equation for T8, and we have to write the general term equation for T2. So T8, okay, so it's T1 plus d times n minus 1. N is 8, so 8 minus 1. So if I simplify that down a little bit, I get T8 equals T1 plus 7D. Okay, we can D7, but mostly we write it in algebra 7D. We usually put the number in front. Okay, so there's two unknowns, T1 and D, and that's what we want to find. So there's one equation. Now we do the same thing for T2. T2 is going to equal T1 plus D, but rather than having 8 there, we have a 2. 2 minus 1. Okay, 2 minus 1 is 1, so this turns into T2 is equal to T1 plus D times 1, which is just D. So that we have our two equations. Now we can plug in these numbers into each equation. So T8 was 108, or 109, pardon me. 109 equals T1 plus 7Ds. T2 was 25, so 25 equals T1 plus D. Now it's up to you how you want to solve it, but I like to just subtract the two equations, solve by elimination, because we both have T1 in them. So we can subtract the bigger equation, we can take that one and subtract the smaller equation. So use elimination to solve. Solve for D by subtracting equations. Okay. All right, so let's do that. Okay, so big one first. Okay, I got 109 equals T1 plus 7D. Subtracting 25 equals T1 plus D. Okay. 109 subtract 25 is 84. T1 subtract T1 is 0, so that's gone. And 7D subtract 1D is 6D. Okay, now we can divide 6 there, and we get that D is equal to, what is that? 6 into that would be 124, so 1 and 14. 14. So the common difference is 14. Now we can simply put D into this one of these equations and solve for T1. So I'm going to use the bottom equation. 25 is equal to T1 plus 14, which is D. Subtract 14 on both sides. 11 equals T1. There's my answer. T1 is 11. D is 14. So when you have two arithmetic sequence terms that you know, you can write two equations, two general equations, and then T1 and D would be blank, and then you could solve them simultaneously by subtracting the smaller of the equations from the larger of the equations. You can either do it the opposite way, it'll still work, because you'll just have a negative number, and then you'll be dividing by negative number. So it doesn't really matter which one you subtract from which one. It will give you a correct answer if you're just doing the subtracting one from the other because you want to eliminate this T1. Okay, so that's the hardest type of question that we can get. So let me just pause here for a second and take a look at what kind of practice work, or maybe if we need to do another example here. Let me check the time. We're sitting at about 29 minutes, so maybe we can do one more example. Let me just take a check here, and I'll be back with you in a minute. Okay, I do want to do one more example here. We're only at about 30 minutes, so you'll have lots of time to do some practice here. But sometimes they just give you an arithmetic sequence, okay, where they just give you a couple terms in it. So they might say, here's another example type. Say they had blank, 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 and then they had 27, and then they had 39. Come on in. Just let me pause here for a second. Okay, sorry, we'll get back on this one here. So this is pretty simple to do. We have two consecutive terms. So if we want to find D, the difference is going to be, well, how much do you have to add to 27 to get to 39? So it's just 39 minus 27, which is 12. So if we go back 12 from here, right? 27, subtract the 12 going backwards. That would give us our 15. Subtract 12 from there, that would give us 3. Subtract 12 from there, we get a negative 9. So there would be filling out the rest of the sequence. So there are some questions like that where they'll just give you blanks, and you can do them just by working it out or writing it out. Okay, so for example, to try, I will give you a few to try here. Let me get to my, not that one, pardon me. Let me get to my little list here that I have. There it is. Okay, so in section 1.1, okay, page number, okay, so this is pages 16 to 18, okay, because it's kind of big. Try, okay, number 2, number 3, 4, 5, okay, do 6, A and C. Let's see what we got there. 6. Don't have to do them all. And maybe try a couple of word problem ones. Let me find a couple more here. My other little list, say maybe number 9. Okay, and we want to try those solving simultaneous ones. I think 16 is like that. No, I'm going to have to show you that one because that one's I'm going to have to do an example like that. Write the general term that relates to the number. Okay, when they say write the general term, let me just stop here and like say, if they say write the general term, okay, they want you to solve for Tn in terms of D and T1. So when they say write the general term, because they sometimes ask that question, they're actually basically, if we go back, they're asking you to write this. 109 equals T1 plus 70. That's what they mean by writing Tn, except this won't be Tn, it'll be T8. So this is the general term. The T-nth, or the nth term, it'll be in terms of you leave it, you plug in everything that you need to do, and you leave it blank. So that's what they mean by that. If you get confused on that, don't be afraid to come and ask me or send me an email or whatever if you're not from the school here, and I can kind of be more specific on that. And you could try number 14. So, and that should be good. Okay, so try 2, 3, 4, 5, 6, A and C, and also 9 and 14. So that should be long enough. That's about 34 minutes. So best of luck. And if you do have questions, don't be afraid to ask. Okay, good luck. See you in day 2.